Dear viewers, my name is Faiz Masurkar and in this video I will be talking about how to estimate polar form of a simple complex number. So let's say if the form of the complex number given to us is in the bracket 1 minus under root of 2 plus I. Now how we can convert this form of the complex number to a polar form? Let us see how we can do that. Let us write the form which is given to us, which is z is equal to x plus iy, which is equal to 1 minus under root of 2 plus I. Now see, this is a form that is given to us. We need to convert this form into the polar form. In order to better understand this, let me draw a figure here. Alright, so I'll just draw a diagram here. Let us denote this as y-axis and this as the x-axis, and let's say this is that point z. And this point z is defined by two variables, which is theta and r. So r is basically the resultant, all right? And here, let's say this is the origin, 0, 0. Now, let's say if we want to convert this into a polar form, so what we have to do is we have to convert z as z is equal to r into cos of theta plus I into sine of theta. If you closely observe this equation, then there are three unknowns. One is r, second is cos theta, and third is sine theta. So if we can find all these three items, we can substitute in this equation of z and we can get the polar form. Now how we can do that? First of all, let us focus on r. So how to estimate r? We know that this r is nothing but the resultant, as we can see in this figure as well. So r, how to find resultant? There is a simple formula, r is equal to x square plus y square. Now, if I compare these two equations, so I can easily get x as in the bracket 1 minus under root of 2 and y will be equal to 1. If I compare the coefficients in these two equations which I am highlighting. So let us substitute this into this equation, and when I substitute, what I get is 1 minus under root of 2 the whole square plus y square, which is 1 square. Now I have to factorize this. So let me use the formula, which is a minus b the whole square. When I use this formula, then this formula is a square minus 2ab plus b square. This is a well-known formula we all know. Then we will just make use of this formula and we will rewrite this equation as 1 minus 2 root 2 plus 2 plus 1. So that will be 1 plus 2 plus 1, that will be 4. So 4 minus 2 root 2. So this is the value of r. Now we have been able to find the first item. Now we need to find the second and third one, which is cos theta and sine theta. Now let us come back to this figure which I have drawn on the right. If I use the trigonometric function, so I can write cos theta as referring to this figure, which is adjacent upon the hypotenuse. So adjacent is this, which is x. So I can write x upon the hypotenuse r. If I write for sine of theta, then that will be opposite upon the hypotenuse. So opposite over here is y. I am referring to theta. So the opposite to theta is y. So I will just write opposite y upon hypotenuse, which is r. Now what I have to do is I have to substitute the values of x, y, and r into this equation of sine and cos theta. So that will give me all the three items. So let us quickly do that. So I will write this equation of z again. Z is equal to r. I'm referring to this equation now. So if I write r over here, so that will be z is equal to r 4 minus 2 root 2, right? And then in the bracket, I have cos theta. So cos theta is over here, which is x upon r. So what is x? X, we have it over here, which I'm highlighting here. So that is 1 minus under root of 2 upon r. R is nothing but again under root of 4 minus 2 root 2. Then plus I of, what is the value of y? Y is nothing but 1, which I'm highlighting again here. So that will be 1 upon, what is r again? Sine theta is y upon r. So I have substituted the value of y. The value of r is again under root of 4 minus 2 root 2. So this is the final answer. So if I have the rectangular form like this, then I can get the polar form like this. So I hope this was pretty easy to follow, and please like, share and subscribe to my channel so you can get more exciting videos like this. Thank you very much. Stay blessed and take care.